Hello folks, welcome to what promises to be a super boring and not very fun-packed video. So if you found yourself here by some freak accident, immediately pause, go up to the search box up there, type funny cat video and press enter. You will be taken away from this horribleness. However, for the 2 or 3 people that wish to continue watching, then welcome. Welcome to, I guess, what passes today as my electronics lab here in the corner of the big barn. So what we're looking at is our ZombieVerter VCU board. And I've been meaning to make this video for some time, but just circumstances didn't allow for it. So one of the reasons I wanted to make this is just that the videos that I had made on it about a year or 2 ago now are a little bit out of date. Not that, there's absolutely nothing changed on the design since then, but as some of you will know, we have had this chip shortage or whatever they want to call it. That basically means that it is difficult and sometimes impossible to obtain, at least for mere mortals such as ourselves, certain semiconductor devices. So again, as some of you may know, some of you may not, I get my boards made in China by a company called JLC PCB. And this board here is just a sample of a latest batch that I got in from them a day or 2 ago. And even if you don't know much about electronics, you can see here that there's some rather glaring omissions on this board. There's the main microcontroller is missing, and there's devices here, and 2 devices there are missing. And the reason, there's 2 reasons these parts are missing. One is that certain parts, such as this guy here, IC 12, which I think is the NCV8461, JLC PCB simply do not have. The other reason is that, say, some of these devices here are the NCV8402 parts that JLC PCB unfortunately are charging way too much money for. The main microcontroller, the STM32F107 VCT6, is a similar thing. They do have some of them in stock, at least at the time of making this video, but I think the price was something over $120 each to get those parts. So I decline with thanks on those, even though it does make the kit build, I guess, more labor intensive for me. So one question I want to address straight away, because it has popped up again and again, and I'm sure it will in this video, is why don't I just say, okay, well, you can charge whatever you want to charge and I'll just pass on the cost to my customers. So could I get these boards almost fully populated every time? Probably. In order for me to then sell these kits to people, I would at the very least have to double the current sale price, probably treble it. And that's not something that I'm prepared to do. And the reason that I'm not prepared to do that is that I realize that the biggest barrier to entry that folks have with EV conversions is not knowledge, it's not ability, it's not a willingness to learn, it's not You know, some of the things you might think of, like access to a car or access to tools or any of these kind of things. The single biggest, commonest barrier to entry is money. And this is kind of what I'm here for. I'm here to try and alleviate some of that, even though sometimes it feels like I'm, you know, 2 steps forward, 3 steps back. Particularly in the last year with all of this, as I say, chip shortage nonsense. Now, for me to say bump the sale price of this unit from, I think it's 350 euros at the minute, to the guts of £1,000, that's simply going to put this, number one, at a price that, you know, folks probably can't access. And number two, it's going to put it up there with the price of some competitor products that, quite frankly, are better developed than this is. Because this is pretty much just me and a few folks who contribute software. There's not a lot of unfortunately, there's not as much contribution on this as as my kind of rose-tinted glasses view of the world would have liked to see. So I hope that it does move along and gets to a more polished point, particularly from the software perspective. I mean, I have it running in 3 of my cars at the minute. It'll be in a 4th one, hopefully later this year. So the design is pretty good, if I say so myself. The software that I'm running now in my own cars is good. I haven't had any problems with it. But there's an awful lot of kind of nice add-on things that I would like to get better integrated. But anyway, enough about that. I just wanted to clarify why I don't simply, you know, or could I get a different PCB maker to make this and they'd populate it 100%? Probably, again, yeah. But again, the price point just jumps up and it's out of reach. And it's just not where I want to be with this, or indeed any of the other board kits that I'm trying to sell there. I'm trying to get things in there so that people can use OEM parts in their conversions without having to spend a fortune on getting the controls. So where that leaves us then is I get these boards, say, in the condition that you see here. Now, again, there seems to have been a bit of confusion out there. Again, despite sometimes me trying to explain things, and sometimes I guess the message doesn't get across, but okay. So let's get this one out of the way first of all. Obviously, I don't have a test rig for this board or any other board, so I do not and cannot 100% hardware test these before shipping them. That's just not something that I have the ability to do. However, nor do I just take a board that comes in from JLC PCB, stick it in a package with a few random components and then ship that. That's not what I do either. And again, this is one of the reasons for making this video, is that I'm going to show you on this board here exactly what I do before, you know, you get the board and the kit of whatever parts that I can supply to fit to it. I also want to explain what you do not have to do. There's quite a bit that I'm going to do here and then there will be, you know, I think we had some folks, you know, trying to program this and having problems doing that, when, as you'll see shortly, I do all that here for you. Now, obviously, again, when it comes to sourcing some of these missing parts here, I will source as many as I can. And I will include those in the kit for you. However, again, as of the time of making this video, which is kind of early June 2022, there are some parts that I simply cannot obtain genuinely. Now, what do I mean by that? Meaning that I can get a package that has the right legs and the right footprint and has all the markings on it, but there's probably no actual silicone in there. That is the curse of fake parts. And again, as a result of the chip shortage, these have, you know, unfortunately became much more common and much more of a curse for us that are involved in electronics. They've, you know, fake parts have been around for as long as electronics, but unfortunately now they're floating around quite a bit. I was unlucky about 2 months ago, I think maybe 2 months ago, no, probably a little bit more now, about 3 months ago, was before I moved house. I had been looking for the CAN transceivers. This VCU board needs 6. Oh, what are they? Heads melted. 6 CAN transceivers. Oh, I can't remember the part number. But anyway, I ordered some. I ordered like 10 from a supplier. Tested 2 or 3 out of the batch. They were fine. Ordered 100 from the same guy. Every single one turned out to be a fake. So that unfortunately did get out to a few customers, because immediately before and immediately after moving house, I was literally trying to ship kits out as quick as I could, and these things were here. I put them in thinking they were genuine, but of course they were not. So got a nice reel of those to put in the bin. The good news is I have gotten myself some new ones, which have fortunately are genuine. Oh, here's the part number, SN65HVD230. So this is one area, so I include anything that I can get genuinely. 2 parts at the minute that I just cannot source are IC12 and IC10. IC12 is the NCV8461 high side switch, and IC10 is the MCP25625 CAN controller and transceiver. I have actually bought quite a few of these, but yeah, guess what? Fakes. So I haven't yet found a genuine supplier for this part, but I'm still hopeful that I will be able to. So that brings us on to where do I get then parts at a much better price point, right? Because say if, for example, JLC PCB are wanting to charge 120 something US dollars for the STM32, well then how am I getting that at a much lower price and being sure that it's not, you know, at best some kind of a reject from the manufacturer that isn't going to perform properly? You know, it might flash a few LEDs for me, but not much else. Oh, sorry about that, folks. Just had a delivery of some timber there. The house renovations are never ending. So, as I was saying, How do I then get parts for less than what they seem to be going for at the market value, and ensure that they're not fakes or kind of semi-fakes? Well, I'm not going to tell you exactly where I source my STM32s from, but I will tell you what they are. They are what are known as SMD rejects. Now, what that means is that most electronic components, surface mount electronic components, are supplied on our reel, and they're fed into a pick and place machine that basically picks them off the tape and plops them down onto the pads. That's how electronics are mass manufactured. So obviously doing that, machine vision is an important part of the process to ensure that the placement head places the part in the correct location. Now the tape where the components are stored is inspected as well. I'll just take out a piece of this tape here. Might be able to illustrate the point a little bit better, because here's some STM32s here. So the tape feeds in, the leader is peeled back, and the camera inspects the part, and then the placement head comes in, picks it up and plops it down. Now, sometimes the camera will spot a problem, a physical problem with the device that's on the tape. And when it does that, the part is basically picked up and put into a reject bin. And then the tape feeds on and the next part's fed into the process. You know, traditionally, parts that get rejected like this from an SMD process pretty much go in the bin. But I guess again now, due to the chip shortage, these parts are now becoming available on the market that we can purchase, and they're perfectly fine to use for hand placement. So the most common defect that you'll get is that at some point during either the reeling or the unreeling or the manufacturing process, you know, something is pressed against one side of the part and has skewed one even of the legs gets skewed, and that's a reject, because obviously it's not going to flow properly for high-speed manufacturing. But if we just want to manually pick a part off a tape and we can hand solder it and correct the problem, well then that's perfectly fine. So pretty much, folks, that's where I get my STM32s. That's what these are. It's where I've been getting them now for quite some time. I'm not going to, as I said, I'm not going to tell you exactly where I get them from. I can even see one of the defects here in this, even without magnification. I can see there's a leg kind of kicked here on that part there. So it'll be interesting now. I'll be able to show you this when I put it on the PCB here. So again, this is where I get all my STM32s, the 103s and the 107s. And they most certainly do not cost $122 US each. And it's little tricks like this that so far, fingers and toes and pencils and crossed and touch wood and whatever this is, fake wood, that I haven't had to change any of my pricing. It does mean that I have to do more work on these. I mean, when they were coming in fully populated, I pretty much programmed them, power tested them, put in a Wi-Fi module, packed them up, shipped them out. But what we'll show you now is what I do for a typical VCU kit. And this will hopefully just make sure that folks don't get confused about what they should or shouldn't do when they get their kit. All right. Okay, so this is not going to be any kind of a soldering tutorial or SMD placement tutorial or anything like this. The purpose of this is just to pretty much show you what I do. So first thing we got to do before we can do anything is put a microcontroller on here. So I've got my flux. What I do is I put a little dab in the middle of each of the I guess sides, like my SMD rejects. And just going to peel back the tape. Got my dot here, so pretty much making sure I get them. And then I just plop them on roughly in the right spot like that. Then using my finger, I'm going to press down just so we squeeze out a bit of that flux into the middle. At this point, I'm going to deploy my first bit of magnification, which is just a cheap kind of a head magnifier with a light on it, and you're going to get to look at my bald head now, which unfortunately is probably not as nice to look at on camera as I think it is. So at this point, what I'm doing is I'm just moving the device around with combination of my finger and the tweezers, and I'm trying to center all of the legs on the pads. And I can see there, yeah, you can see why that's an SMD reject. There's actually two reasons. There's one leg, this last leg here on this side has been kicked out, and there's a tiny little bit of corrosion, I think, no sorry, yeah, tiny little bit of corrosion on a leg here as well. So that's why the pick and place machine decided that one was for Damien and not for some consumer product along the way. So now that we have our part in the middle, I get a nice big chisel tip soldering iron. And again, just holding my device in the middle, just put a little solder there like that. May seem a little bit counterintuitive to people that I'm using a really big soldering iron tip, or you know, should I not be using some tiny little thing? And the reason is we're not trying to individually solder each of the legs. That's, I guess, one of the common mistakes that people make. Best way to solder this style of an SMD part, in my opinion, not that that matters, but is to, what did I call it? What's the name of it? Drag solder. That's what I'm doing here now. I'm just making sure I get my legs as central on the pad. So I put a blob of solder at 90 degrees, and then I just basically walk it onto the center, making sure that I haven't screwed it up as badly as I sometimes do. But I think I got that one okay. So now I'm going to now start my drag soldering. And in order for this to work, we need to use the Lewis-Rossmann amount of flux. So always use the right amount of flux, folks. That is key to these endeavors. Remember, we're not trying to individually solder 256 pins. Not only would that take a very long time, but it would probably not work out the way you think it would. Instead of that, we're going to solder them all at the same time using a big blob of solder on the end of the soldering iron. And as I said, the Lewis-Rossmann quantity of flux. And getting the legs of that device, I should say, as central on the pads as I can, is kind of key to the process. I mean, it doesn't, don't get me wrong, I'm no expert at this. It doesn't always play out like that for me. I screw up as much as the next person. Actually, sometimes more than the next person. And have I put these on in the wrong orientation? Absolutely. Absolutely doodly. Now, so once we do that, inevitably what happens is, as we draw the iron off, we get a little bit of solder bridging, as the excess solder needs to be just wicked away from the very end. Then we just run our tip again, like that. I did have a little USB microscope thing that I could have filmed this for you with if you wish to regale yourselves with my skills or lack thereof, but either A, it hasn't survived the house move, or B, I can't find it. Hoping it's more B than A. So now my next bit of magnification is this little handheld thing, so you're going to get to see more of my head now going in. This gives me about a 12x mag. And ooh, that's pretty decent if I say so myself. Good so far, 2 down. 2 for 2. 3 for 3. Okay, and there I've got another defect leg there. So there was one that had got past me. Good job I'm not a machine vision camera. My time as a pick and place machine would be severely limited, because there was one more leg that must have been kicked up a little bit. Yeah, there he is. He didn't get soldered because there was one leg that was kind of pushed up like this more than his friends, and thus he would have been that's be another we got him. That would have been another reason that part was rejected. Sad for the part, obviously, but happy for us. Now, oh yeah, that's got him. So, assuming I haven't put this on the wrong way around, which I don't think I have, and assuming there's no bridges in here or opens that I can't see with this little thing, then we should be all set for the next phase. Now, normally, the next phase would be applying 12 volt power. But on this particular batch, sadly for me, JLC did not fit L3, which is the big 68 microhenry 2 amp inductor for the main 5 volt power supply. So we get to do that. Yay us. So this is one I removed from the board. I'm still waiting on some of these to come in because I wasn't obviously expecting these not to be placed. So I'm going to go ahead and fit these. And before you ask that question, yes, I will be fitting these. I will be fitting these prior to shipping the boards, and the reason for that is that I need them on here so I can do a power-up test, which we power-up test and we program all of our boards prior to shipping them out so you don't have to. And so at the very, very least, you end up with a programmed board that is power tested and not, repeat, not dead on arrival and not needing to be programmed. Now, a better way of doing this inductor on here would be to heat the board from underneath with the hot air. So I might actually do that if this doesn't work out. Now this iron is very, very powerful, so it can get a lot of heat in here. It can put a lot of heat in, so I'm kind of hoping that works okay for me. So it's in. It's not very straight, but it is in. Now, next phase, we're going to do 2 steps here. We are going to power test the board, and we are going to program it. So now I need something to sit the board up on. This will do. So first of all, for a power test, we got to turn on my power supply. There we go. Power supply's on. And we got to activate the power supply. So what I have is I have a ground wire, which goes in here like that. And I have a 12-volt wire, which would go in here like this. And have I screwed up? I hope not. So the first thing we're going to see here, and I'm going to make sure you can see this on camera here. Can you see it? Yes, you can. There's a red light on. It says 3V3 on, which means that our board has power, because our board derives 3.3 volts from 12 volts. Sorry, 3.3 volts from 5 volts and 5 volts from 12 volts. So if we have 3.3 volts on, we have all of our supply rails up. So that's the first thing that you should see. If you do not see that, then you're either not applying power correctly or there's a problem. Now that problem can be in the power supply, or it can be, for example, if we had short-circuited, some of our pins here, we would be causing the power supply circuit to shut down. So what I'm going to do now is I'm going to program I'm going to attempt to communicate, first of all, with our STM32. Now, is this going to work? Don't know. There's many reasons that it may not work. It may not work because I've gotten stung again by fake parts. It may not work because I have somehow screwed up here. There's a pin I haven't soldered. Could be because I'm not, data, wait, hang on, clock data. Yes, it could not connect because I have the pins in the wrong way around. As you can see, this is all very professionally done here for your, oh yay, communication. All right, now, I'm going to get my fingers out of the way, and I'm going to, the first thing I'm going to load into the microcontroller is the bootloader, so STM32 loader.hex. And I'm going to program and verify that, and done. Then I'm going to get STM32 VCU.hex. There we go. And I'm going to program and verify that. Now, it's now programmed. We can now get rid of our programmer. You do not need the programmer now, or barring something super weird going on ever again. So, again, let's see, can we see this on camera? Yes, we can. We now have a second LED. It's flashing 10 times a second. Written beside it is ACCTY, short for activity. So, that means the software that we've just loaded into our microcontroller is executing. And when it is executing, that means that it's alive, it's good. So at this point, what I'm going to do next is I'm going to get myself a little paintbrush. I'm going to use some flux remover and some IPA, and I'm going to get rid of all the flux that I used to put the STM32 on there. Stand by. Alright, so that's all the flux cleaned off. So what I'm going to do next is I'm going to power up the board again. And the reason that I do that is just to make sure that when I was brushing off the flux and all that, I didn't dislodge a pin that caused a short or something silly. So again, we're just going to power up the board, and we see that we have our 3.3 volts on LED and our activity LED flashing away merrily here. So what I would do here now at this point in the process of making the kit is I would program a Wi-Fi module and then include as many parts as I have available to me, as I explained, that I can source genuinely, and make up the kit and ship it to the customer. Now, I'm not going to show you me, putting parts in a bag and programming a Wi-Fi module, that kind of thing, but you're probably already bored to tears, so no point pushing it. So this is it, folks. I just wanted to update you on the state of play with our VCU. Hopefully quash some misconceptions that may have been out there about what does or doesn't need to be done when you receive a kit, and explain why there are, still some missing bits. Indeed, if there is anyone out there that knows a source particularly for the NCV8461 and the MCP25625, do please drop a comment below and let me know. At some point in the future, I would love to be able to get these fully assembled up, tested, ready to go, so that folks don't have to get involved with any of this. I'll be getting back onto some of the software design fairly soon, because I have some other features I want to implement and so on, but I've got a lot of pressing stuff going on at the minute, as I'm sure folks can understand. So lastly on this, just again, I just find myself again having to super clarify this. I do not provide one-to-one support for this or any kits or any products. The support for this, and again all of the other things, is provided via dedicated support threads on the Open Inverter forum, where a lot of the time it is actually me answering the questions anyway. But the reason that I insist upon doing it, well, one of the reasons I insist upon doing it through the forum, is that I'm not just answering the same question again and again and again. It's there for all people to see. So I'll put a link in the description to the support thread for the VCU, and also the wiki page on the Open Inverter website, which is really good now. Folks have really done a lot of good contributions on that, so many thanks. Right, I think that's about it. I'll leave it there. As always, do not forget to dislike, do not share, do not subscribe, and for Pete's sake, folks, don't support me on Patreon and PayPal and things like that, because then I'll just do more of this kind of thing. And let's face it, who wants that? So, that's it. I mean, until next time, happy non-fake chip sourcing.